Okay. What I want to talk about today was another cipher. It's called the Beaufort Cipher. And it was named after this guy who lived from 1774 to 1857. I'll write some things down about him. He was born in Ireland, and then he, like, when he was super young, I think it was when he was like 13, he ended up joining like the British Navy. And he like worked his way up. And he had a successful like naval career. And at some point during his career, he developed this cipher. But it actually wasn't published until after his death by his brother. And then he's also known for something that's still used today called the Beaufort wind force scale. I think it's used by meteorologists to like detect like how strong winds are. I didn't look too much into it, but I just thought it was interesting that he's also known for something else. But okay, enough like historical background. Like let's just talk about like how this works. Okay, so the idea is kind of like with the from last video with like the Veneer cipher, with the Veneer cipher, we want to keep using this idea of having a keyword that's going to help us encrypt our plain text. So what we're going to have, we're just going to pick a random plain text. So let's just say our plain text is going to be boat, and then our keyword is going to be like frog. Okay. And then we want to somehow use this cipher to encrypt the plain text boat with the keyword frog into some sort of ciphertext. Okay, so the first thing we're going to do is we want to convert all of these to numbers. And this is really from me over here, so I can like see what we're doing. But yeah, we're just gonna assign every letter to a number. So just kind of looking at this chart, right? This is gonna become 1, 14, 0, 19, and this is gonna become 5, 17, 14, and then 6. Okay, so what we're going to want to do here is we're going to want to subtract these first. And we're going to get, just our resulting values, we're going to get -4, -3, -14, and 13. Okay, then what we're going to do here is we're going to mod these values. So we're going to take these values, mod 26. Now what this means is we're going to divide these numbers by 26 and then take the remainder, right? So just as like an example of what we're doing, right? If I were to take 60 mod 26, this is gonna let's just do like long division. So we do 60 divided by 26, right? This is gonna be 2, 2 remainder 8. So we just want this value. So 60 mod 26 is gonna be 8. Okay. And then now the tricky part with modding is that how do we do with negative numbers? So if we have something like, I'm not gonna pick these numbers. So if I have like -7 mod 26, I'm just gonna take I'm just gonna add these numbers together, right? So this is gonna be equal to 26 or -7 plus 26, and this is gonna be equal to 19. That's how we do with negative modding. And then lastly, how do we deal with numbers that are less, right? So before we did 6, it was greater than 26. We did negative numbers. So what if we have something like 15 mod 26? Well, if we think about this, right? If we're asking for the remainder, right? When we do 15 divided by 26, right? 26 goes in 0 times with remainder 15. And this is always going to be the case when we have some number less than 26 or less than whatever we're modding out. So, sorry, if we have like 13 mod 26, this is going to be 13. Okay, I gave that one away. I was accidental, but okay, so we'll just reveal that one. So 13 mod 26 is going to be 13. Okay. And like I said with the negative, when we do mod 26 with the negative number, we're just gonna add these together, right? So -4 mod 26 is gonna be 22. -3 mod 26 is gonna be 23. And then -14 mod 26 is gonna be 12. Okay, and now the final step here is we want to go from our numbers back to letters. Okay, so now we see that 22 maps to W, 23 maps to X, 12 maps to M, and then 13 is gonna map to N. And then this is gonna be our how we encrypt this. Yes, this is how the Beaufort Cipher works. And I think these are pretty cool because, or at least these ciphers with these keywords is because you can have like lots of different combinations. So like you can have like your one plain text and then a bunch of different keywords, and then like for all like your infinitely many different keywords. Oh, not infinitely, but for all the different keywords you can have, you're gonna get a different like output with the same plain text. So it's kind of cool. It's kind of hard to break this. So